Hi everyone, my name is Morgan Moore and I'm a technical artist at Xbox Rare. In this tutorial, I'll be going over the fundamental workflow of taking a Groom from Houdini and transferring it over into Unreal Engine along with various relevant attributes. So in this example project, we have a chipmunk model and its completed Groom split into three main sections. Now in Unreal Engine there is a Groom plugin which basically handles all things hair in the game engine, and there are two main approaches to visualizing hair for this plugin. So firstly strands, which is very similar to what you'd have in Houdini in terms of thousands or even millions of curves, and then hair cards, which is a mesh generated based on the Groom curves, and this can be created either in Houdini or Unreal. So we can start by creating an geonode, and within that creating an object merge node. So in this case our Groom is split into three different sections, so we can merge them together. You might not need to, and within that object merge we can then reference each of those different sections, and then once we've done that we can take the output and plug that into the first input of the lab's Unreal Groom export node. And then we can drop down another object merge node and grab a reference to the skin geometry. So the lab's Unreal Groom export node will basically handle a lot of the export process for us, and what it does is basically convert our Groom into Alembic primitives suitable for Unreal Engine, and it will also make it very convenient to add attributes such as UVs, color, width, groups, which can all be read by Unreal Engine's Groom plugin. So at this point we could already export the Groom as Alembic and bring it into Unreal Engine, and already it's transferring the UVs from the skin onto the hair, assuming you have UVs on your skin. However, if we want to add other attributes like width and groups, then we can take a few further steps. So for writing the attributes, we can use the paint attribute node, and the first one we'll look at is width. So for width, we can name the attribute width and then change the attribute type to keep that at float, and then we can adjust our brush settings. So to start with, we don't want any area to have zero width, so we'll start with a fill of a value of something like 0.1. The scale of these attributes can be changed in Unreal Engine, so I'm just going to keep everything in a 0 to 1 range, and then that can be scaled up or down within Unreal Engine. So So then we have a 0.1 value to start with. Then we can change our brush to volume. So in this example, it's probably quite subjective where you would want thicker hair or thinner hair, but just for the sake of demonstrating how to write the attribute, we'll say that we want thicker hair on the back and some thinner hair on the face. So once you're happy with that, you can then move on to the next attribute, which is groups. And again, this is optional and may not be necessary for what you're doing, but I will demonstrate it anyway. So we can create a new attribute paint node, and we need to name the attribute as the same value that we have in the labs Unreal Groom export node under Groom ID attribute. So we can copy and paste that. So that is Groom group ID. We can copy that into the attributes panel of the attribute paint node. And then we can set the attribute type to integer, because it can either be in a group or not be in a group. It's binary. And by default, the chipmunk is set to group 0. So it's 0 indexed, and we can paint as many other groups on top of that as we want. So again, it's completely sort of subjective what areas you'd want as separate groups. So in this case, we'll just do the body as the default 0 group and the tail as group 1, so that we can control their parameters slightly differently in Unreal Engine. So now we can start painting out the group attributes and change the brush size where needed. So the reason we paint groups will be a bit clearer later, but essentially in Unreal Engine you'll be able to adjust different groups independently. So maybe you'll want simulation on one section of the fur, but you don't want it on the whole creature because that would be too expensive. Or maybe you want a different material type on it in a different section, or maybe you want to reduce the number of curves in an area. So that can all be done when you split your groom into different groups. And finally, in order to match Unreal Engine's Groom plugin specification, we need to promote the Groom group ID attributes to primitives. So there are quite a few other attributes that can be added. For example, you could bring over the output color on the actual mesh. But in this case, because we're bringing over the UVs, I think we'll just use textures instead in Unreal Engine. And another option, as you might have noticed, there is a third input on the Labs Groom export node, which is for guides. So if you want to explicitly define the guides that you want on your groom, that will then be used as part of simulation in Unreal Engine, if you want simulation. And in this case, we'll just use Unreal Engine's automatic selection of guides. So you can basically select a certain proportion of the hair that will become guides, and you'll see that a bit later. And yeah, from that point we can simply export our groom and just render the current frame and click Save to Disk. So before we move into Unreal Engine, we will have a quick look at generating hair cards. And hair cards are basically an alternative to using strands in Unreal Engine, and they're typically less expensive than strands. So we can start by again creating a geo node, and then within that creating an object merge node, and then referencing our merged groom object from the strand section. And then on the second input, we need another reference to our skin reference. So we'll get that. We can then plug in the hair and skin references into a hair card gen object. So once we plug in the skin, we will see hair cards generated based on the default settings of the hair card gen node. And from this point, we can start making adjustments. So firstly, we can click on Ignore Short Curves and change the minimum curve length to 0 if we want to include all the curves. So I'll set that to 0. And then we can have a look at the number of hair cards, things like the width scale, the number of divisions, how we want to divide along the length, and the bend of the card. So if you want them to curve around a bit, it might give it more of a 3D look to it. So there's lots of parameters to play around with there. So one of the main things that we might want to do with the hair cards is get the color data from the skin onto the cards within Unreal. This could be done either via vertex color or using textures and UVs. In this case, I will look at using textures and UVs, as I think this will give us a bit more flexibility for the materials in Unreal. So if we simply plugged in the output of the hair card gen and the output of the skin into an attribute transfer and tried to transfer the UVs from the skin to the hair cards, we would have a lot of issues with overlap, as you can see if we go to a double pane tab and view the UVs. And this would cause issues if we tried to apply a texture to it. So instead, we will follow a different process, and instead of changing the UVs to match the texture of the skin, we will change the texture to match the UVs of the hair cards. And to start with, we will create an attribute VOP to transfer the texture color to the color attribute on the skin. So if we create our attribute VOP and then connect the first input to our skin, and then within that create a texture and connect our UVs to the UV channel on the texture, and then the color attribute to the CD attribute of the geometry. And then we just need to specify the texture that we are using for the skin. Actually, one thing we need to change on the attribute VOP is to make it run over vertices rather than points, so that we have access to the UV attribute, which is on vertices. And if we delete the material from the skin input and view the attribute VOP, we can double check that the color is coming through now on the CD attribute. Next, we can use an attribute transfer to transfer the color attribute from the skin onto the cards. And this will be done based on the nearest point. Now that we have the color attribute on the hair cards, we can go about creating a new texture map for the default card UVs. To do this, we can firstly create a null output for our hair cards, and then navigate to the image network and create a labs attribute import node.
We can then set the resolution of our output texture and reference our hair cards.
And on the attribute import node, we can see a preview of what the texture will look like. So that looks correct based on what our UVs looked like. Once this is configured, we can create a ROP file output node. We can then set the output directory for our image, and in this case, uncheck convert to image formats color space, and then click render.
Lastly, for the hair cards, we can place down a ROP alembic output and export the hair card mesh. So before we start importing our assets, we need to make sure that we have the two Groom plugins enabled. So that's the Alembic Groom Importer plugin and the Groom plugin. And then in the project settings, if we search for support compute skin cache, we need to enable that so that we're able to bind our grooms to the skin. Within Unreal Engine, I've gone ahead and imported some of our assets. So firstly, our textures, so our hair color, our skin color. So hair color and skin color are quite similar, just hair color is some minor adjustments on top of the skin color texture. And then the hair card texture that we made in Houdini. And then we have created two blank materials that will be creating for our cards and groom. And then under skin, I've imported my base skin FBX mesh with an animation. And then finally, I've created a level for the chipmunk work. And next, we will import our groom assets. So firstly, our cards. And what we need to change here is we'll just scale it up by 100 on scale, and we'll rotate it 90 degrees just for the transfer from Houdini to Unreal's coordinate space. And we can save that. And then we will bring in our groom asset. And here we'll have a rotation of minus 90 on the X and 180 on the Z. And again, we'll scale everything up by 100. And here we can see that our groups have come in correctly. So we've got group 0 and group 1. Group 1 being the tail area that we painted in. And under interpolation settings, we can have a look at our hair to guide density. So as I said previously, in Unreal, we can control what proportion of our strands will be used as guides. So since this is quite a dense groom, we can probably reduce this quite a bit. So we can go 0.01. So every 100th hair will be a guide. And we'll do the same for the second group as well. So let's close this first one up. Change that to 0.01. And there's also decimation settings here, but I think it will be better to adjust them in once we've imported it in the Groom asset so we can see exactly what effect using the curve decimation and vertex decimation will have. So from there, we can simply import that. And I'll go ahead and save that. And now I will go ahead and create our materials. So firstly, we can start with this very simple one. So we'll do the body. And for this, we will create a texture. And we can drag and drop our texture reference in. So this will be the color for the skin. Once that's in, we can plug that into base color and save that out. Next, we can go to our Groom material. So again, we'll start by creating a texture sample. And by default, it has the color skin already set up there. Now, the difference here is Unreal's Groom plugin for strands, it requires a specific shading model. So there is the hair shading model, and we need to set it to this, otherwise it won't work within the Groom asset. And the second thing we need to change is we need to enable used with hair strands. And once we have both of those plugged in, we need to reference our hair UVs that we set in Houdini. And that will be under the hair attributes node here. And we can plug in root UV into UVs. And we can save that. We can then go to the cards material and create another texture. This time we will reference our hair card texture. We can close that. Now, because this will be used for cards, we are not limited to the hair shading model, so we can leave that at default lit or whatever shading model you want. And the one thing we do need to enable is we need to enable use with hair strands again. And that is all we need. The default UVs will work because we didn't change them. And we can save that. So now that we have our materials ready, we can move on to creating a binding asset for our Groom. And what this will do is allow our Groom to deform as the skin of our base mesh deforms. So if you have an animation, it means it'll allow the Groom to deform with the animation. So to show this, we will first just grab a reference to our chipmunk skeletal mesh. And we will then go to our Groom assets, right click on our chipmunk Groom asset and create binding, and then paste our reference. And once we've got that done, we can create. And then save that. One thing to be careful about with the binding asset is to ensure that our Groom asset and our skeletal mesh line up correctly. So usually before you create the binding asset, you would just make sure that they're the same scale and same rotation. And in this case, we can see that they are. So our binding asset should be fine. And from here, we can then create our blueprint. So we'll just create a simple actor blueprint. and call it Groom-BP. We can open that up, and we will first add our skeletal mesh. And we still have that attribute copied, so we'll just paste our skeletal mesh. And then parented below our skeletal mesh, we will add our Groom asset. And here we have a space for the Groom asset and the binding asset. So we'll just find our Groom asset there. Then our binding asset. We can save that. One thing we need to go back and do is just open up our Chipmunk Groom asset. And within here, we can see a bunch of tabs. And the first thing we'll do is we'll just add that material that we created. So then we can grab our Groom mat material. And once that's in, we can see that the texture color has been transferred to the chipmunk strands. And then we can save that. And if we go back to our blueprint, we should have everything ready to go. Yep. And if we drag and drop our blueprint into the scene now, we can see our fully textured chipmunk with its groom. And if we go to our skeletal mesh and add our animation, we can now see that our binding has worked correctly. Next, we can have a look at doing the same for hair cards. So what we can do is we can duplicate our chipmunk groom asset. So even though it's cards, we still need the base groom setup. So we just duplicate this and we can rename this chipmunk cards. Now, hair cards could be used by themselves, or they could be used in combination with a groom asset. So in some areas you could have strands, in some areas you could have cards, or you could use cards as an LOD in order to save on performance. We can then open up our cards groom asset, and within that we can add two materials. So the first one being our strand material, be this one. And for the second one, we will add our cards material. And then under cards, we can add our cards asset. We'll change this to our second material that we added for the cards. We'll change this to imported. And then we will drag and drop a reference of our cards mesh. Now that that's set up, we can go to LOD. And we can change the geometry type from strands to cards. And that will update that. And we can do that for the second LOD as well. And now we have our textured cards within the groom asset. Now, like what we did with the strands, we will add our cards asset to a blueprint. So we will go back to our main folder and we can duplicate our original blueprint and rename that to cards BP. If we go in here, we can remove the strand groom asset, and we can reference our cards example. And the one thing we need to make now is our binding asset. So if we firstly save this, and then go to, well, firstly, I'll just grab a reference to our skeletal mesh. And then if I go back to our cards asset, I can go to create binding, paste our reference to the skeletal mesh, and click create. One additional thing we can do is go to the cards material and change it to two-sided so that we can see the cards from all angles. And then I'll just save that. We can then go to our cards blueprint. And we can then add our cards bind asset. So that's here. Then we can compile and save that. And in our viewport, we should be able to see that that's set up. And we can grab that and drop that in our scene. And we can see a very basic cards chipmunk setup. Now, usually you'd spend a lot more time with the material. We simply just added a texture and did nothing else. So that's something you could do outside of this tutorial. And if we add animation to our skeletal mesh again, we can double check that the bind asset has worked. And yep, there it has. And before we finish this tutorial, there's a few other things we can have a quick look at. So if we go to our strands chipmunk groom and open that up. As I said previously, we were going to have a look at the curve decimation and vertex decimation. So we can see that there's about 1.2 million curves here and about 5 million vertices. So if we take a look at what halving the number of curves looks like, we can see it's actually quite a subtle difference. So if we go back, we can actually get away with removing quite a lot before we have any real significant visual difference. And we can also reduce the vertices. This will also help with performance. For the vertices, you'll need at least twice the number of curves because every curve needs at least 2 vertices. And so on. You can keep adjusting these until you have something that sort of balances the visual quality and performance that you're looking for. And you can do that with the second group as well. The final thing we'll have a look at is, well, actually 2 other things. So firstly, we can have a look at LEDs. So it's got a very powerful LED system. So you can simply click the plus button on your group and And just to clarify, this is like 100% of what we set on the base. So this is actually like 0.5 and 0.7 as opposed to 1 and 1. So it's still taking over those values that we set under the interpolation tab. And then by default, when I created LOD1, it's reduced the curves to 0.5 and the vertices to 0.5 as well. And we can see if we zoom in and out, it will actually blend between LODs. So you won't have any issues, or you shouldn't really have any issues with like popping between different LOD groups. And we can see that when it takes up a screen size of 0.5, it'll be at these values, and at screen size of 1, it will be the full sort of resolution that we have there. And you can carry this on, you can do as many LODs as you want. As I said previously, one of the LODs could be cards, so you can change the geometry type. I could change this to cards. And if I had something in the card section here, that would populate that. And the last thing we'll look at is physics. So one of the reasons that we painted groups, so we can see here, obviously we can adjust groups independently. We can also add, if I go to the strand section, you could also add like a different material. You could change the width, you could change the scale of the hairs independently per group. And you can also, if I go to the physics section, we can also independently, we could have physics on one part and not on another, and we could also have different types of physics. So in this case, for the tail, which is the first group here, group 1, index 1, we can enable simulation. And the first thing I will do is just disable collision for the moment. It would take a bit more time setting that up to work with collision properly. But if we click enable simulation, and back in the main level, we can see the simulation has updated on the tail. If we click play,
we should be able to see a subtle difference.
And that is everything for this tutorial. Hopefully that gives you an idea of the basic workflow of bringing a groom from Houdini into Unreal. You could spend a lot more time on this and go into a lot greater detail, but
we should be able to see a subtle difference.
A good introduction. So thanks very much for listening, and we'll end it there.